we're going to integrate square root of 1 plus x squared. This is a basic integral where we'll be using trigonometric substitution. Now, the integral we have has the following radical, or the radical of this type in there. It's a type a squared plus x squared, where a is a constant. Matching this to our problem, we see that a squared must be 1 squared, or 1, and we can take a to be positive 1. Whenever you have square root of a squared plus x squared in your integral and the regular u substitution doesn't work, we'll be using trig substitution by letting x equal to a times tangent theta. Now in our case, a is 1, so the substitution is x equal to tangent theta. Now from here, you need to take the following steps. First, differentiate the left-hand side, that's dx, and then as well as the right, that becomes secant squared theta d theta. And then replicate what's inside the radical. So inside the radical we have 1 plus x squared. X is tangent theta, so we'll square both sides. X squared becomes tangent squared theta. Add 1 to both sides. 1 plus x squared equals 1 plus tangent squared theta, which is equal to, by using trig identity, secant squared theta. Now return to the integral. Get rid of the x's, replace the x's in terms of theta. 1 plus x squared is replaced with secant squared theta. Dx is replaced with secant squared theta d theta. We can assume the square root of secant squared is secant, and our integral becomes secant theta times secant squared theta d theta. And of course, this simplifies to the integral of secant cubed. Now, I strongly suggest for these problems in trig substitution, memorizing the integral of secant cubed as well as the integral of secant, because that will come in handy. In an earlier video, I derived the integral of secant cubed by using integration by parts. I'm going to derive it here by not using integration by parts, but instead using what's called a reduction formula for secant. Here's a reduction formula for secant. Secant to the n of theta d theta is equal to 1 divided by n minus 1 times secant to the n minus 2 of theta times tangent of theta plus n minus 2 divided by n minus 1 times the integral of secant to the n minus 2 of theta d theta. The reason it's called a reduction formula is because the integral on the right, the power of secant, is reduced by 2 from that on the left. Now in our case, n is 3, so for that the formula becomes secant cubed, the integral of secant cubed of theta equals 1/2 times secant theta tangent theta. You just replace every n with 3, and that's what we have, plus 3 minus 2 is 1 over 3 minus 1 is 2, so that's 1/2 times the integral of secant theta d theta. Now, you should memorize the integral of secant. It's also derived in an earlier video. And we have the integral of secant cubed theta d theta. It's 1/2 secant theta tangent theta plus 1/2 the integral of secant, and that's natural log of absolute value of secant theta plus tangent theta. Now let's return to the integral that we started. The integral we started with was the integral of square root of 1 plus x squared. Now after making the following substitution, x equal to tangent theta, we ended up with the integral of secant cubed of theta d theta, and that is equal to 1/2 secant theta times tangent theta plus 1/2 times the natural log of absolute value of secant theta plus tangent theta. The problem is this is not the answer we want. Our original integral was in variable x. We want the answer also in variable x. So substitution was tangent theta equals x, which we can write as x over 1. I'm going to draw a right triangle that looks something like this. This is a right angle. Call this angle theta. Now tangent is opposite. We call that x, over adjacent. We call that 1. And I hope everybody sees that the missing side, the hypotenuse, is square root of 1 plus x squared. This one way to check this is to use the Pythagorean theorem. The other way is to know that the missing side, whatever that happens to be, will almost always be the square root that we have inside the integral. So inside the integral we have square root of 1 plus x squared. That will be our missing side. So here's our final answer using variable x. Secant theta is hypotenuse divided by adjacent. So we have 1/2 times tangent theta. Tangent theta is x. And then times secant theta, which is square root of 1 plus x squared over 1. So we can write it as square root of 1 plus x squared, plus 1/2 natural log of absolute value secant theta, that's the square root of 1 plus x squared, plus tangent theta, that's x, and then we add c at the end. So this is the antiderivative of square root of 1 plus x squared. For